I will gonna present the periodic table group of element lanthanide. Lanthanide is lanthanum. The source of lanthanum is silver white metallic element. It is belong to period 6 of lanthanum element. Lanthanum is found in rare earth minerals such as cerite, monazite, lanthanide, and basnasite. Was discovered by Swedish surgeon and chemist Carl Gustav Mosander in 1839. Cerium. Source of cerium is one of the most abundant of the rare earth metal, which is abundant as copper and nearly 3 times as abundant as lead in igneous rock of earth crust. Cerium is named from the asteroid series, which in turn was named from the Roman goddess of the agriculture. Sirius was discovered in 1803 by Jacob Berzelius and Wilhelm von Singer in Sweden. The source, praseodymium, occur along with other lanthanide elements in a verified of the mineral. The two principal sources are monazite and basnasite. It is extracted from this mineral by ion exchange and solvent extraction. The history of praseodymium was discovered by Carl F. von Besbeck, an Australian chemist, in 1885. He separated praseodymium as well as the element neodymium from material known as neodymium. Source of neodymium is the second most abundant of the rare earth element after selenium and is almost as abundant as copper. It is found in minerals that include all lanthanide elements such as monazite and basnasite. The history of neodymium was discovered in Vienna in 1885 by Clark Aurel. Its story began with the discovery of selenium, from which Carl Gustav Mosander extracted titanium in 1839. Next is pyrimidinium. Pyrimidinium is a radioactive metallic element of the rare earth group obtained as a fission product of uranium or from neutron irradiated neodymium. The history of pyrimidinium was first produced and proved the existence of Oak Region National Laboratory in 1945 by Jacob M. Merinsky, Lawrence E. Gladinin, and Charles D. Correll by separating and analysis of the fission product of uranium fuel irradiated in the graphic rector.
Next, the element in lanthanide groups is samarium. The symbol of samarium is Sm. It is found along with other lanthanide metals in several minerals, the principal one being monazite and basnasite. The samarium is separated from the other components of the minerals by ion exchange and solvent extraction. The electrochemical deposition has been used to separate samarium from other lanthanides. The history is samarium is one of the rare earths that perplexed and puzzled the chemists of the 1800s decades. In 1879, Paul Amai extracted didymium from the mineral samarskite. He observed that the precipitate which formed came down in two stages. The first precipitate was revealed to be a new element, samarium, by measuring its spectrum. Other elements in lanthanide is europium. It is found in the minerals monazite and basnasite. However, the usual method of preparation is by heating europium 3 oxides with an excess of lanthanum under a vacuum. In 1886, John Charles extracts gadolinium from samarium. In 1901, Eugene carried out a painstaking sequence of crystallization of samarium magnesium nitrates and separates yet another new elements observed. There is europium. Next, gadolinium. The symbol of gadolinium is Gd. It is found in the mineral monazite and basnasite as other elements. It can be commercially prepared from these minerals by ion exchange and solvent extraction. It is prepared by reducing anhydrous gadolinium fluoride with calcium metal. The gadolinium is discovered at Geneva in 1880 by Charles Galiside. Other elements in lanthanide is terbium. The symbol of the elements is Tb. It is obtained from euxenite, a complex oxide containing 1% or more of terbium. The metal is usually produced commercially by reducing the anhydrous fluoride under a vacuum. The history of the terbium is it is first isolated in 1843 by the Swedish chemist Carl Mosander at Stockholm. He had already investigated cerium oxide and separated a new elements from lanthanum and focused on yttrium, discovered in 1794. In fact, Mosander was able to obtain two other metal oxides from it. There is terbium oxide in yellow color and terbium oxide in rose pink color, and this is he announced in 1843. Next is dysprosium. As usual, the element is found in the mineral monazite and bastnasite, also in smaller quantities in several other minerals such as xenotime and fergusonite. It can be extracted from these minerals by ion exchange and solvent extraction. Paul Emile discovered dysprosium in 1886 at Paris. Its discovery came as a result of research into yttrium oxide, first made in 1794, and from which other lanthanide were subsequently to be extracted and finally found dysprosium.
The next element is holmium. Source: holmium is found as a minor component of the minerals monazite and bastnasite. It is extracted from those ores that are processed to extract yttrium, and it is obtained by ion exchange and solvent extraction. Holmium is usually found in the ores monazite. Pure holmium can be obtained through the reduction of holmium fluoride with calcium metal. History: Swiss chemist Jacques Louis Sorel and Bernard de la Fontaine discovered in 1878, and Swedish chemist Berthander independently in 1879. Cliff separated it chemically, named the element for his native city of Stockholm. Its Latinized name is holmia. Erbium. Source: erbium is never found as a free element in nature. It is found in minerals that include all the rare earth elements and one of the more abundant rare earth elements. History: Carl Gustav Mosander has discovered the element as an oxide in 1842. He originally called it terbia in the confusion arising from the similarity in the properties of the rare earth element. The name of two, terbium and erbium, became interchanged. Thulium. Source: thulium is found principally in the mineral monazite, which contains about 20 parts per million. It is extracted by ion exchange and solvent extraction. Never found in nature in pure form, but is found in small quantities in mineral with other rare earths. History: thulium is named for Sweden, the earliest name for Scandinavia. First isolated in 1879 as its oxide by Berthander Cliff at the University of Uppsala, Sweden. Ytterbium. Source: ytterbium is found with other rare earth elements in several rare minerals. It is most often recovered commercially from monazite sand, which is 0.03% ytterbium. Ytterbium is the 44th most abundant element in the Earth's crust, present at about 2.728 parts per million in the crust. The element is also found in euxenite and xenotime. History: Jean-Charles Galisard, Jean-Marie Inet, Lars Fredrik Nielsen, which identified the element over a period of several years, beginning in 1787. Merida reported an analysis of a sample element called erbia in 1879, which is isolated from yttria, so it consists of two elements called erbium and ytterbium. The last element in lanthanide is lutetium. Source: lutetium has no known biological role. It has low toxicity. In common with many other lanthanides, the main source of lutetium is the mineral monazite. It is extracted with difficulty by reducing the anhydrous fluoride with calcium metal. Never found in nature as the free elements, lutetium is found in the ores monazite sand and bastnasite. History: lutetium was discovered in 1907 until 1908 by Austrian chemists Carl R. von Welsbach and George Urban, working independently.
Now, I'm going to tell the physical properties of lanthanides. First, lanthanide is silvery white in color. Second, it is a good conductor of heat and electricity. Third, lanthanide is a strong reducing agent. Fourth, many of the lanthanide's ions form colored ions due to FF electronic transition. Fifth, Lanthanide generally have high melting and boiling point. 6. Lanthanide relatively soft metal. The hardness increase somewhat with a higher atomic number as the atomic size decrease, so the packing become more compact in solid state in lanthanoids. That's why the hardness increase. 7. They exhibit paramagnetism because of the presence of unpaired electrons. 8. Moving from left to right across the period, the radius of each lanthanide's 3+ ion steadily decrease. This is referred to as lanthanide contraction. What is lanthanide contraction? The lanthanide contraction is the result of a pure shielding electron of the 4f electrons. This shielding effect is described as the phenomenon by which the inner shell electrons shield the outer shell electrons so they are not affected by nuclear charge. While, in the other hand, the chemical properties of lanthanide is they readily tarnish in air and burns to give oxide. All the elements in lanthanide give oxide except for cerium, which forms cerium dioxide. The lanthanides react readily with most nonmetal, for example, nitrogen, sulfur, hydrogen, and form binaries on heating with most nonmetals. Third, it reacts with hydrogen ion to release hydrogen gas rapidly at room temperature. The lanthanides reacts with water to liberate hydrogen, slowly in cool water and quickly open heating. Lanthanide commonly bind to water as stated in the chemical reaction in the slide. Lastly, lanthanide compounds are generally predominantly ionic and usually contain lanthanide metal in its +3 oxidation state.
Application of lanthanides. These are characterized as metal and alloys, non-nuclear use, and nuclear applications. Metal. First, metal atomic reactions. Lanthanide is used for this due to its reducing properties. Second, as deoxidizing agent in manufacturing of copper and its alloys. Alloys. First, production of alloy steel for plates and pipe. Second, use in magnesium-based alloy to produce bullets, shell, and lighter film. Nuclear application. First, the ceramic industry uses lanthanide oxide to color ceramic and glasses. Optical lens made with lanthanide oxide are used in cameras and binoculars. Second, in lamps, von Welbes was also the inventor of the gas mantle, which uses thorium and cerium oxide and allow gas lighting to be widely used. The last one is non-nuclear use. The lanthanide has a variety of nuclear application. First, because they absorb neutrons, they have been used in control rods used to regulate nuclear reactors. Second, they have also been used as shielding materials and as structural components in reactors. Third, lanthanide oxides are used as diluents in nuclear fuel. Fourth, and as radiation source, example European for alpha rays.
Effect through environment. The lanthanide compounds are moderately to highly toxic. Generally, the toxicity depends on the nature of the lanthanide compound, on a route of the administration, and on a dose. Researchers had long assumed that lanthanide toxicity rate was low and therefore safe to implement in a number of high-tech breakthroughs with no tech from degraded from organic, like limiting display to medical MRIs and even hybrid vehicles. Okay guys, this is tips to memorize lanthanide element. Lily cari piring, nak peras susu enak guna tisu dalam handbag mak tapi sambil lewat.